OSCANN is an eye tracker designed for the study of the most prevalent neurological disease, such as Alzheimer's or Parkinson's. The system consists of a high-speed camera able to measure eye movement alterations out of predefined visual stimulus. Image capture, stimulus control, and data analysis is performed with a single software developed by ORTE. OSCANN is an easy-to-use device. It only takes a few quick adjustments to place the patient and start capturing data. Depending on the pathology, a specialist can configure which test has to be performed. Before making a test, it is necessary to calibrate the system. For this purpose, the patient has to look several predetermined points on the screen. Afterwards, the test can be conducted. Some of the tests that can be done with OSCANN are saccades, smooth pursuit, images, pupillary light reflex, optokinetic. The software interface is intuitive. It allows to process the test with a single push of a button, and in less than 5 minutes the results can be obtained. After the tests are processed, the interface shows the graphs of the movement of the eye. There are different visualization modes especially adapted to each type of test. Since the videos are stored in the computer, the specialist can see the recorded video with its corresponding graph synchronized. It allows to analyze in depth the patient's response during the test. When the tests are finished, a report is generated automatically, showing the results and highlighting the most relevant parameters, such as response time, precision, and number of microsaccades. These graphs, using real data obtained by performing a resultant saccade with OSCANN, show the difference between a healthy patient and one diagnosed with Parkinson's level 2. The blue curve shows the eye movement and the red curve shows the trajectory of the visual stimulus. Difference between the curves can be easily observed at a glance. The fixations of the patient diagnosed with Parkinson's contains several involuntary eye movements, called square wave jerks. Also, reaction and gaze settling time are bigger. The healthy patient takes considerably less time to reach the stimulus.
The human arm is the most flexible joint in the entire body. According to the World Health Organization, 1,700 people suffer from a musculoskeletal injury, where upper limb injuries correspond to more than 20% of the total. We present ORTE, a unique human upper limb exoskeleton created to improve treatment and diagnosis of any upper limb skeletal muscle disorder. ORTE has been designed to increase the quality of life of patients and enable practitioners to provide more efficient and productive rehabilitation sessions. Our ambition is to deploy ORTE everywhere needed, so patients can benefit from this technology. We aim to reach this goal through licensing agreements with distributors with global reach. Its price, versatility, and simplicity makes ORTE unique in its class. Nowadays, there exists no way for physicians to obtain functional data that can aid in the diagnosis or rehabilitation process of patients. ORTE will provide groundbreaking solutions so that the physicians can adapt the treatment to the patient's evolution. Moreover, ORTE will allow physicians to treat more than one patient at a time, increasing productivity and enabling cost savings. In ORTE, we imagine this to be the future of rehabilitation, and today we are making this possible.